Hi everyone. This lesson is the second part 2 of factoring out a monomial greatest common factor. Actually, in the last lesson, we only learned how to find the greatest common factor between two quantities. And now in this lesson, we're actually going to be factoring out a monomial greatest common factor from a polynomial. So it's very important that we know how to find the greatest common factor between two quantities or three. For example, in number 4, which is something that we did already, what we do to find the GCF is break down these two quantities as much as we can, and then we look for the things that they have in common. So the 8x is 2 times 2 times 2 times x, and 4x squared is 2 times 2 times x times x. So what do they have in common? They have 1, 2, a second 2, and they have an x. And the GCF is the multiplication of those things that they have in common, which is 2 times 2 times x, which is 4x. That is how we find the GCF. Of course, we need to practice as much as we can, because we need to be able to find the GCF between two or three quantities just mentally. We should not need to do these procedures to find the GCF, but for now we can use them. So the second part is what we're doing today. Factoring using the greatest common factor. That means from these polynomials that we see, we're going to be factoring out the greatest common factor. So let's start with an example of or connect to what we have learned before or what we should know. The factorization using the greatest common factor is simply the opposite of the distributive property, of the multiplication using the distributive property. For example, if I have 3x plus 5, then we multiply using the distributive property by doing the following. By multiplying the 3 times the x and 3 times the 5, because we have really here a multiplication between these two quantities. These are two factors, 3 and x plus 5. They are two factors. And when we have that situation, the way to multiply is by multiply this monomial by each term of the polynomial inside the parentheses. So that such that the result of this would be 3 times x, 3x, and 3 times positive 5, that will be positive 15, since 3 is positive and 5 is positive, positive times positive, positive 15. So that is a distributive property. The factorization is the opposite. We will start with the answer and get these two factors. So we will be given 3x plus 15, and then we're looking for what are those factors that are multiplied to get this. And what goes here outside the parentheses, here goes the parentheses, and what goes outside the parentheses is the GCF. That is how we use the GCF. So what we need to do is we need to find the GCF between these two quantities. What do they have in common, these two quantities? So if we break down these two quantities, that is 3x plus 15, 3x, I need to break down each of them. 3x is simply 3 times x, and 15 is simply 3 times 5. So that thing that they have in common, that will be the GCF. So the only thing that they have in common here is a 3. So that is the GCF is 3. So that goes here outside the parentheses. And now we think about what is left inside the parentheses from each of these terms. So if I take the 3 from the 3x, what am I left? Because the 3 is already here. If I take this 3 out, I'm only left with the x. Or you could use here the decomposition of the terms. If I take the 3, I'm only left with the x. So that x goes inside the parentheses. And now think about the second one. If I take the 3 from the 15, what am I left with for the second part here? Well, the 15 is 3 times 5. If I take the 3 out, because it's already out here, I'm left with the 5, which is positive. So that will be plus 5. So as I said, we're starting with the answer, and I'm looking for these two terms. So if you multiply this, you should get this back. So 3 times x is 3x, 3 times 5 is 15. Two things that you should check to make sure that it is correct. One, after you do the factorization, there should be nothing in common between these two terms inside the parentheses. For example, in this case, there is nothing in common between the x and the 5. There are no more things in common because everything that the two terms have in common should be here. That's the greatest common factor. Everything, the maximum, the greatest thing that they have in common, it's already here outside the parentheses. So there should be nothing in common. And the other thing that you should check is that if you multiply this with a distributive property, you should be able to get this in order for the factorization to be correct. And as we did before, 3 times x, 3x, 3 times 5 is 15. So that means this is the correct factorization using the greatest common factor for 3x plus 15. So try to do this work like on a separate piece of paper. It should not interfere with the question and the answer. This is the question and this is the answer, and you do this work. If you need to do it, you do it on the side, on the margin. Otherwise, you can try to do it mentally, because you should be able to find the GCF mentally. If you just look at 3x and 15, what do they have in common? There's only a 3 in common between the 3x and the 15. There's nothing else in common. Here, this one has an x, this doesn't have an x. So there's only a 3 in common between this term and this other term. That goes here. So let's go to the exercises. I'm going to try to do as fast as I can. Well, actually, I'm going to do some of them only, not all of them. I'm going to leave some for you to do. I'm going to do number 1, and I'm going to do number 3, and 5, 7, and 9. Those are the ones that I'm going to do. The other ones I'm leaving for you to practice. And number 1 is very similar to what we just did. What is there in common? What's the maximum thing that they have in common, 3x and 6? There's only a 3 in common, because 3x is 3 times x and 6 is 3 times 2. So there is a 3 in common. If you need to write it down, you can do it, but try to do it mentally. 3x is 3 times x and 6 is 3 times 2. So the only thing that they have in common is the 3. So that's the GCF, 3. And that is what goes here outside the parentheses. And then the parentheses come. So 3 goes here. Now we think about it. You can do it. You can think about it in 2 ways. What do I need here so that when I multiply 3 times this thing, I get 3x? How can I get 3x? What do I need here? Well, I need an x because that's the only way to get 3x. 3 times x would give us 3x. Or you could think about the other way that I said before. If I take the 3 from here, what do I have left? If I take the 3 from 3x, I'm left with an x, and that x is what goes here. So the same thing for the other one. This should be a plus. So you can think in two different ways. What do I need here so that when I multiply 3 by this quantity, I get 6? How can I get 6? Well, that has to be a 2 because 3 times 2 is 6. Or again, you think about taking out the 3 because the 3 is outside already. Taking out the 3 from the 6, what do I have left? I have left a 2. That 2 goes here. So that when I multiply 3 times x, I get 3x, and 3 times 2, I get 6. So that's the factorization of 3x plus 6. Also double check that after you finish the factorization, there should be nothing in common between these two terms inside the parentheses. In this case, there's nothing in common. So that's the end of number 1. Number 3, again, we think about the GCF. What does 8a squared has in common with 6a? There's definitely an a in common because both of them have a. This has two a's, but this has only one, so the maximum that they have in common is 1a. And then what there is in common between the 8 and the 6? There is only a 2 in common between these two numbers. So the GCF should be 2a. Or if you really need, you write down the decomposition of these terms. So 8 is 2 times 2 times 2 times a times a, and 6a is 2 times 3 times a. What do they have in common? They have a 2 and 1a, nothing else. They have nothing else in common, so that goes outside the parentheses. And now, what do I need here so that when I multiply by 2a, I get an 8? How can I get an 8? An 8, well, I need a 4 because 2 times 4 will give us an a, so I need a 4. And how can I get an a square? I just already have, well, I have only one a. I need another a in order to get a squared because a times a would be a squared. So that is what is left. Or you could think about it. If I take out the 2a from here, what do I have left for this part? Take out the 2a, 2 and 1a. I have left 2 times 2, which is 4, and 1a. So what do I have left for the other part? Here should be a minus because there is a minus here. And what do I have left? If I take the 2 and an a, I'm left with a 3. Or simply, what do I need here in order to get a 6? Well, it has to be a 2 times 3 to get 6. And since I already have an a here, I don't need another a because I only want one a. And that's the end of the factorization. Notice one more time that there is nothing in common between these two terms. And if you multiply this using the distributive property, you do get back this one. 2a times 4a, that is 8a squared, and 2a times negative 3, that is negative 6a. Next one, number 5. What there is in common between these two terms? Again, we can try to do it mentally, and between the numbers, there's only a 4, a maximum of 4 in common, and between the variables, there is an x in common. This has two x's, but this doesn't. So the only thing that they have in common is an x. This has a y. This doesn't have a y, so there are no y's in common. So that's the GCF for x. Or you could break down this and find out. So that is going to be 16x squared. That is 2 times 2 times 2 times 2. That's 16 times x times x. 12xy is 2 times 2 times 3 and times x and times y. What do they have in common? They have a 2, another 2, so that is 2 times 2, 4. And they also have an x in common. So the GCF is 4x. That is what goes there. And now, what do I have left inside the parentheses? Or what do I need here in order to get 16x squared when I multiply these two? To get 16, I need another 4 over here. And to get x squared, I need another x over here. So it's going to be 4x, because that's the only way that I can get 16x squared. 4 times 4, 16, x times x, x squared. Or you could say, what do I have left from 16x squared when I take out 4x from there? So I take out 4 and 1x. I'm left with another 2 times 2, 4, and another x. And on the other part, what do I need here? So that when I multiply 4x times this term, I get 12xy. I have a 4. The only way to get a 12 is by multiplying it by 3. So it's 3 here. Now I also have an x here, but I already have the x here, so I don't need another x here. And I also have a y here, and I don't have a y in the GCF, so I need the y here, 3y. Or you could say, if I eliminate, or if I take out 4x from 12xy, what do I have left? So take out 4x, that's 1, 2, that's another 2, that makes 4. Take out the x, and I'm left with 3y. That is what goes here. And that's the factorization of this binomial. Again, there's nothing in common between these two terms, and if I multiply this using the distributive property, I do get back the 16x squared, because 4x times 4x is 16x squared, and then 4x times 3y, I get positive 4 times 3, 12. X, there's no other x to multiply with, so I have this x. And then here there's no other y to multiply with, so I have this y for this part. I'm leaving number 6 for you, which is very similar to number 5. In number 7, we have 3 terms, but they're relatively simple, so you can see the GCF right away. For example, this doesn't have a variable, so there are no variables in the GCF. So there are only numbers in common. What's the biggest number that there is in common between the 4, the 8, and the 12? Well, that has to be a 4. So the GCF is 4, because 4 is 4 times 1, and then 8 is 4 times 2, and 12 is 4 times 3. So all of them have a 4, and that's the maximum, because remember, we want everything that they have in common. The maximum, the greatest thing that these numbers have in common is a 4. And there are no variables in common between the 3 terms. So the GCF is 4. Take it outside the parentheses and see what remains inside the parentheses. From this term, it remains x squared, because that's the only way to get 4x squared when I multiply by 4. I took this 4 out and I'm left with x squared. From the middle term, if I take a 4 out, a 4 from the 8, that means 4 times 2. So if I take a 4 out, I should be left with a 2 and the x and the negative sign in front of the 2x. So that when I multiply by 4, I should get 4 times negative 2x, I get negative 8x. And then from the 12, I have left a 3, and that's positive 3, because 12 is 4 times 3. If I take the 4 out, I'm left with the 3. Notice one more time, there is nothing in common between these. This doesn't have a number, it has only a 1, this has a 2, this has a 3. There's nothing in common between the numbers and the variables. This doesn't have x, so there is nothing in common between these three in terms of the variables. And if you multiply with the distributive property, you do get back this original polynomial. So it is correct. And finally, and by the way, number 8 is very similar to this one. The only difference is that the GCF here for this one is not a number like in number 7. It's going to be a variable, because that's what they have in common. Notice that we have an age in all of them, so that's what they have in common. Or you could write down the decomposition of each of the terms and find out what they have in common. So the last one that I'm going to do is number 9, and that's actually the easiest one, because there's no decomposition to do. You could simply you can see right away what is it that they have in common between this term and this term. There is an x in common. There's definitely an x in common, so there's no need to be looking for it. This has an x and this term has an x, so that's what they have in common. That is the GCF. So the GCF is the x. So you take that x out and see what do you have left. Well, if I take the x out from the first term, I have a c left. There's a minus in the middle. And if I take the x out from the second term, I have a d left. And that's it. Notice one more time that there is nothing in common between these two terms. And if I multiply this with the distributive property, I do get the original polynomial. X times c is xc. And then we have plus times a minus, minus. And x times d is xd. So that is how we factor out the monomial GCF, or that is how we factor polynomials using the GCF. We find the GCF between the 2 or 3 terms of the polynomial, and then we write it outside the parentheses, and then we find what are the things that are left from these terms after you take out the GCF. You're factoring out the GCF from each of the terms. What do you have left, or what do you need in these places, so that when you multiply with the distributive property, you get back the original polynomial. And that's it for factoring using the GCF. Please, as always, make sure you are doing your homeworks and keep on task and doing the homework on time.